So we've seen what the graph of a basic exponential function looks like. But remember, to get the whole family of exponential functions, we can also compose exponentials with linear functions. And so the most general form of an exponential function looks something like this, where we've got something linear happening in the exponent. Then we actually apply the exponent, and we've got something else linear going on outside. To graph this, we're going to use the same strategy that we used in a lot of our graphing, like the absolute value or the quadratic. But we're going to make it explicit because we're on our way to doing something even more complex with this. So what we're going to do in order to graph this is think of this as we've got some sort of a basic function, and then we're doing stuff to it. So here we have an example of an exponential function, and the very basic part of this, the simplest part, is that we're taking 3 to some power. We can think our base function is 3 to the x. And the way we're going to start planning our graph is to think about not our big complicated function, but our base function, which takes some number and raises 3 to that power. And we're going to think about the input of that function. We'll take maybe -2, -1, 0, 1, 2, just to get a range of values. And then we'll take 3 to each of those powers. So 3 to the -2, that's 1/9. 3 to the -1, that's 1/3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. Okay, so how are we going to use that? In our example, our input, that is the power that we're taking 3 to, is this half x minus 3. So these inputs are a half x minus 3. To find the actual value of x, well, half x minus 3 is -2 in this first row. So that means half x is +1, x is +2. So in our first row, our x value is +2, because then half of that minus 3 gives us our input, -2. We can do the same thing with the next row. Eventually, we're going to see a pattern here. Okay, we've got half x minus 3 is -1. Half x is 2, so x is 4. In the next row, we have x is 4. We'll do one more, and then we'll see what the pattern is and make use of that. Half x minus 3 is 0. So half x is 3, x is 6. So what's going on here is this is something linear. So we expect going up by 1 in the right column is going to be going up by some constant in the left column. We can see that we're counting by 2's over here. So we're counting by 2's in the left column, right? And we'll double check. A half of 10 minus 3, that's 5 minus 3, really is 2. Okay, so that actually works. So this column is going to give us our x values when we go to actually draw our graph. We're going to find our y values in this column. And how are we going to find those? Well, in our specific function, we're taking -2 times what we get when we take 3 to the something and adding 5. So to get the y values, we're going to go from this column. To get the x values, we went from this column. So to get the y values, we're going to take -2 times this number plus 5, which, totally a job for a calculator, that gives us 4 7/9. We want a mixed number because we're going to graph it. Make sure it looks like a mixed number and not a fractional exponent, just so you can tell what you meant. If we take -2 times 1/3 plus 5, that gives us 4 1/3. -2 times 1 plus 5, that gives us 3. -2 times 3 plus 5, that's -6 plus 5 is -1. And -2 times 9 plus 5, that'll be what, -13. Now, we have a small problem, and that is that drawing all of these numbers is going to be kind of a pain. So I'm going to just kind of choose nice numbers to graph. In order to do that, I think I don't want that row, because x is 10, y is 13. I don't like either one of those. I definitely want this row, right? 8, -1. I definitely want this row. 6, 3. Yeah, I like those. And then these two I'm just going to kind of take into advisement. So let's see. I want my x-axis to go out to 8. I need my y-axis to go up past 5 and down to at least -1. So I'm going to draw axes that look something like this. So there I have my axes. Totally not interested in any negative values of x. If I had a little bit more space here, I'd probably have a wider range of y values. But that's enough to capture everything I really need. So I've got 8, -1, that's here. I've got 6, 3, that's here. And then I've got 4, 4 1/3, right? So 4 1/3, that's about here. And then 2, 4 7/9. 4 7/9, that's going to be pretty close to 5. Okay, so remembering the shapes I saw before, it looks like this is upside down. And that makes sense, because these numbers are going to keep getting close to 5. Right? Because this fraction keeps getting smaller, and then we've got something negative times that fraction added to 5. I think our horizontal asymptote then, we're going to get close to 5. Our horizontal asymptote is up here at 5. And then our graph gets close to that as we go off to the left. And then we can see even in this row that it's going to rapidly get really big negative as we go off to the right. Okay, so what happened here? Remember, our general form is f of x is a x to the something linear in x plus something. Our horizontal asymptote here was at y equals 5. In general, the horizontal asymptote will be at y equals k. Why? Because the horizontal asymptote happens when this gets close to 0. And so we have 0 plus something. And then in our example, the graph was upside down. It was below the asymptote. And the reason that that happened is that this term was negative. Right, so we were adding something negative to our 5. We ended up with numbers that were all less than 5. So the reason that that happened was that our A is negative. When our A is negative, our graph will end up living below the asymptote. And then, ideally, we want at least 2 key points. We'll actually want 3 if we're drawing by hand to get a better idea of our shape. Even more is even better, but we want at least 2 points. And to find 2 nice key points, one strategy that often works is to find the places where the input, not x, but the input of the base function, to find the places where that has the values -1, 0, or 1. Depending on the base, that will usually give us 2 nice points and 1 fraction. And also depending on the value of a. Sometimes we'll get lucky with the value of a, and they'll all be nice points. Sometimes we'll get unlucky and they'll all be fractions. And then we need to just deal with the fractions in our graph. But we'll look at those 3 key input points, and that will usually let us get the basic shape of our graph, along with the horizontal asymptote.